Today I'm going to be talking about sending data via endpoint other than the default 0. Namely, we'll be sending interrupt requests. They are not much different from the ones we used before. Their feature is that they are really fast. For control request, it would be okay to have a little bit of a delay and transmit message 10 or 20 milliseconds later after it has been requested. In contrast, interrupt transfers happen in a defined period. Their delay cannot be larger than some predefined value. This time, this maximum delay, may be as small as 1 millisecond for full-speed devices and 125 microseconds for high-speed. So, to make use of this new endpoint, we'll have to make a couple of modifications. We'll have to include it in the device configuration. It's the only way the host would know this endpoint even exists. The driver won't be able to use it otherwise. So, I will add another block to the configuration descriptor, something called endpoint descriptor. Let's take a closer look at it. Conveniently, its first two fields, like all the other descriptors, are length and type, with endpoint descriptor type being 5. These fields are followed by endpoint address, type, maximum packet size, a 2-byte field, and little endian. So if the packet size is 8, the field must contain bytes 8 and 0. This is followed by a field called period, meaning how frequently the host will be asking the endpoint for the data. Next, the communication itself. It's a little bit different. For control transfers, we had a function called setup callback, called every time a transfer has been requested. Well, there is no such callback in the interrupt requests. We have to request the transmission of data on the host side. The host will start polling the device for some data. Then when the device is ready to send the message, it will request the transmission itself, and the data will appear on the host side. After that, the polling stops. The host will need to request another transmission if it expects another event to happen. Quite simple. That being said, we are ready to move on, back to writing the code. First, I will add an endpoint descriptor to the configuration so that the system knows the device uses interrupts. Its length will be 7 bytes, its type ID is 5, endpoint number is 1, and it's an interrupt, thus its number is 81 in hex. Its packet size will be 8 bytes and period will be 3. And I forgot to add an endpoint type here after the address. Interrupt type ID is 3. Now I'm gonna add a function that will watch the state of the button and transmit the interrupt if necessary. I will call it USB periodic. It will keep the information about the old button state, check the new button status. I have changed the development board and the button is now attached to another pin. And if the new button status does not match the old one, it will print out a message, update the old status, and send the message over USB. Now, this function needs to be called from the main loop, so I'm inserting it here. It takes the USB handle as a parameter. I'm fetching it from the USB initialization function. Now building it to make sure there are no errors, it builds fine. Opening SVO console, the device is not attached to the host, so there are no USB messages. The periodic function is working though, and if I press the button, the message is printed. Now it's time to give some attention to the driver code. I won't need the control request anymore as it will be substituted with interrupt request. I will need to update the pipe, but first find its definition. It's located in the same file as the old one. The one I need is called rcv-int pipe for receive interrupt pipe. I'm copying into my code and creating the pipe. The device remains same as before, but endpoint number is now 1. Next, I'm gonna find the definition for the function that sends the request. It's called similar to the old one. I'm copying into my code and passing the right parameters. It doesn't take values like request type or value. It only takes a pointer to a buffer and length of the data. After the transmission is done, this variable called actual length will contain the number of bytes that were transmitted. It may be smaller than the actual buffer size. I'm building and loading the module, restarting Wireshark and sorting my device. It's being assigned number 27, reading the file. For some reason I don't see any requests in Wireshark, but the log indicates that the read operation did execute. This means it's time for troubleshooting. I will start by checking if the command has executed with an error and print it to the log if so. Rebuild the module, read the file, open the kernel log. The error seems to be 22. I will look inside the code of the send message function to figure out what that means. This function happens to be wrapper for another function, so I will look inside this other function as well. This other function returns an error in a couple of places. I will take a look at the first one. Appears to be 22, meaning that some argument was invalid. Looks like it's thrown when there is something wrong with an endpoint because my length is not less than 0. I'll go ahead and look when this function returns invalid value. Well, it looks inside the list of endpoints inside the device structure. The device structure knows about endpoints from the descriptors. There is no other way, so there is something wrong with the descriptors. They don't indicate the device has interrupt endpoint number 1, so let's go back to the device code. Here I'm looking at the configuration descriptor, and you may have spotted the error already. The number of endpoints is set to 0, so the host may haven't paid attention at the endpoints at all. It's a quick fix and I'm ready to switch back to the host machine. I'm checking the log, reading the file. There is still an error in the log, but it has changed. Error 71 is a protocol error, meaning that the endpoint is not configured correctly. That's a device-side error, so I'm switching back. The problem is the endpoint was not activated at all. I can take the activation function from the reset callback when we are activating endpoint 0. It has to be inserted here when the set configuration command is received. Its number is now 1 and maximum packet size is 8, but here I still forgot to update the endpoint type. I'm gonna figure it out in a moment. For now I'm switching back to the host machine and making one more attempt. The error is still 71. I'm opening Wireshark to check out the requests. Here I notice the error description eProto, suggesting that the error is still related to the device endpoint. Switching back to the device, updating endpoint type, 3 stands for interrupt. I'm starting to debug and I'm about to encounter one more problem. This will be the last one, I promise. These problems may not be obvious to fix and I wanted to have as many as I could in this recording. So, I made another attempt to read the file and the device ended up in the hard fault handler. So the error has happened when the device was attempting to send a message about the button status. I'm going through the call stack and noticing here that the system tries using out endpoint, although it should be an in transaction. While going further back in the call stack, I've noticed that the endpoint number is 255, way off its valid range. This kind of invalid value suggests that the device is looking at the wrong memory at some point. I'm doing another step back to inspect the parameters I'm providing. Checking the pointer to the USB handle, it's 0, so I didn't provide the handle in the main loop. It looks like that I did, but I'm missing the ampersand character. Beauty of the C programming. I'm launching the device again, making the request, pressing the button, and now it seems working, so let's take a look at the host perspective. I'm reading the file and execution freezes until I press the button on the device. The kernel log indicates that the driver had received a message that the button was pressed, but not that it wasn't released. That's because the driver had sent only one request. Any subsequent messages won't arrive to the driver unless it requests them. So we need to make those interrupt requests continuously in order to catch all the events on the device. That's what I'm about to do in the next video, so see you then.